Hello students, today we are going to take chemistry and the topics will be valence shell, valence electron and valency. These three topics are very simple to understand. In 7th standard you might have learned how to get the valency value of each of the elements. But today we are going to talk about, or we are going to learn how valency is calculated. You got the point? So the calculation is very easy, but before that I will explain you a little bit about atom, what exactly atom is. I'll not go much in depth because you might have learned in class 7 standard, but still. So what exactly the atom? Atom is nothing but a smallest particle of any element which cannot be further divided. You got the point, which cannot be further divided. So this is an atom. This is an atom. So let's not give this dot as an atom. Let's consider the entire circle as an atom which cannot be further divided. Got it? Now, what is the heart of the atom? The heart of the atom is known as nucleus. Nucleus. So, this is the atom. Atom. Now, what is the subatomic particle of the atom? Like, what are the things we have inside the atom which is smaller than atom? We have electron, proton and neutron. This is the basic one and we all know about this one, but I must tell you about this one because if I have to explain you about the valence shell, you must be knowing about what is electron, proton and neutron. So this nucleus contains proton and neutron, and this electron, the one which is negatively charged, this electron will be revolving around the nucleus. This will be revolving around the nucleus from one direction to another direction. You got the point? But these electrons will not be sitting randomly around the nucleus. They have certain position where they are going to sit. You got the point? So this is known as shell. This is known as shell. S-H-E-L-L. Now, not all the electrons will be sitting in one shell. You have one more shell here. You got the point? So few electrons will be sitting here. This is shell 2. I'm just naming it as shell 1 and shell 2. One more shell is going to be here, okay, where few electrons will be sitting. So this is shell 3, shell 4 and so on. So electrons will be moving around the nucleus, but where the electron sits in the shell and it revolves around the nucleus. So shell is also known as orbit. So what I said, that shell is also known as orbit where electron sits, right? And just now I said that electron moves around the nucleus. So this statement is not exactly true, but according to the old model proposed by Niels Bohr, electron revolves around the nucleus. But as per the modern quantum model, this statement is not that correct, but okay, this is advanced one. Probably you will get to know a little later once you go in class 9 or so. But as of now, just keep that in mind that according to the old model proposed by Niels Bohr, electron moves in a orbit around the nucleus. Fine. Now, here I have named it as shell 1, shell 2, shell 3, shell 4. But what Niels Bohr has done, he has okay, let me make this picture in a bigger frame so that you'll understand this one. Now this is nucleus, okay, this is nucleus, and nucleus has got proton and neutron. Now this is the first shell, this is the second shell where electron resides, this is the third shell, and the last one which I am drawing is the fourth shell. So these shells are not named as shell 1, shell 2, shell 3, shell 4, but technically these shells are named as K, L, M, N and so on. So the innermost shell is known as K. After that, the second innermost shell is known as L, and then this is M, and this is, okay, let me write M, and this is N. You got the point? So the shell is named as K, L, M, N, depending on the energy level. Now what exactly the energy level is? For the time being, you understand in this way that the innermost shell has low energy. After that, L will have more energy, M will have more energy, and N will have even more energy. You got the point? So the energy level will keep increasing from shell to shell. So the K will have less energy. Perfect. Now, what is valence shell? Valence shell is nothing but the outermost shell of an atom is known as valence shell. I'll tell you. See, when you go with the atomic configuration of any atom, then how the things will be. Example, what Niels Bohr says, that in each of the shell, let's say K is the first shell, L is the second shell, M is the third shell, and N is the fourth shell. Let's consider for the time being only these four shell as per the class 8 standard, right? So Niels Bohr said that how many electrons can be accommodated in each of the shells. How many electrons can sit in each of the cells? You got the point? Let's say there are 5 rooms. So how many people can stay in each rooms? It's pretty simple. In one room, probably in the ground floor, only 5 people can stay. On the first floor, 10 people can stay. On second floor, 15 people can stay. So this is the limit given by the owner. You got the point? You cannot accommodate more than the limit given by the owner. So the same thing is, Niels Bohr has found, as per his theory, that each of the shell can accommodate how many electrons. So the formula is 2n to the power 2. N is nothing but the number of shell. Okay. So example, if I do this mathematics, 1 to the power 2, how much it is coming? 2 into 1 equal to 2. It means the first shell, the K shell, can have maximum of 2 electrons, not more than that. Like that, if you calculate this one, 2 into 2 to the power 2, 2 into 4, 8. Okay. So the L shell can have maximum of 8 electrons. It can have less also, but it can have maximum of 8 electrons. Now the third one if you do, then 3 3s are 9, 2 into 9, 18. It is coming as 18, and then so on. You can calculate accordingly, right? Now what happens? There is something called, so you understood, right guys, that in each of the shell maximum electrons can stay based on this formula, 2 into n to the power, like n square, you can say, n to the power 2, okay, where n is nothing but the shell, 1 2 3 4. Now the next thing is, let me remove this. Okay, let's say I don't remember all the 20 elements in the periodic table, so don't worry. So let me get this one. Example, I must talk about carbon. Let's talk about carbon. So the carbon has the atomic number 6. Okay, so the electron will be placed as, so what I said, let's make a table. 2, 8. Okay, 2 must be kept in K. So what will happen? K will have 2, then out of 6, then A will have 4. Isn't it? Did you get that one? Carbon 6. Yes. So the atomic configuration is 2, 4. This is how you have to write. It means in the first shell, you will have only 2 electrons, and in the second shell, it can have maximum 8 electrons, but it will have only 4 electrons because carbon has only 6 atomic number. Let me tell you neon. Example. So neon has 10 atomic numbers. Okay, neon has 10 atomic numbers. So in K shell, it can only fit 2 electrons. In L shell, it can fit 8 electrons. Yes or no? Here in terms of carbon, L shell can have maximum of 8, but since only 4 are left, so it was having only 4. So 4 plus 2, 6. So it is matching this one. But in neon, all 8s are fixed. But after neon, if I go, let's say, let me go for silicon. Silicon has 14. Silicon has 14. Okay. So what will happen? K will have 2. L will have 8 because I cannot have more than 8 in L, and 8 plus 2. And then M will have 4. Understood? Now in all the 3 cases, the outermost shell is known as valence shell. In all the 3 cases, the outermost shell is known as valence shell. Okay, this is the outermost shell. In case of neon, in case of silicon, this is the outermost shell, is known as valence shell. Now, what is the valence electron? Valence electron is nothing. In the outermost shell, what is the total electron fits in? So, in case of carbon, in the outermost shell, we have only 4 electrons. So, the valence electron for carbon is 4. For neon, in the outermost shell, we have kept 8 electrons. So, the valence electron for neon is 8. For silicon, the valence electron, the outermost shell is M. And how many electrons we have kept it here? 4. So, the valence electron for silicon is 4. Pretty simple. And the last one is valency. So, in order to make you understand the valency, I have to remove this one. It's pretty easy. But before that, you need to understand what is the octet rule. What is the octet rule? And how it is connected to stable atom. Stable atom. Okay. So as per the octet rule, okay, not like that. In order to make an atom stable, you should have 8 in the outermost shell. This is the formula. Okay. I'll explain you. Example, neon. Let's say neon. Neon has 10 atomic number. It is pretty simple. You know this, right? So K shell has got 2 and L shell has got 8. So what I said, neon, okay, in order to make a stable atom, the outermost shell should have 8 electrons. When this kind of thing happens, it means this element or this atom is a stable atom. You got the point? Now, why 8 comes into the picture? Because of the octet rule. Octet means 8. That's why 8 comes into the picture. Now, I'll give you more example. See, I'm just taking the name of, let's say, magnesium. Magnesium has 12 atomic number. Okay, magnesium has 12 atomic number. Magnesium. So how the magnesium will be written? 2, 8 and 2. Now in this case, the outermost shell does not have 8. So this is not stable. You got the point? This is not stable because it does not have 8. It has only 2 because after adding 2 plus 8, 10 plus 2, 12, magnesium is getting filled. Now how you can have more stable, like one more stable atom, 2 plus 8 plus 8, 8, 8, 16, 17, 18. So what is there in 18? Argon. Argon is 18 atomic number. Now you see 2, 8, 8. So this is the stable atom because in the outermost shell you have 8. You got the point? Now here, guys, here what is said in the previous example, that the third shell, let's say K, L, M. M can have maximum of 18 electrons. But here, what I'm saying, that if it has only 8 electrons, then it will be known as stable atom. It will be known as stable atom. So this is different, this is different, okay? This is a maximum capacity electron can have in that particular shell. But if we have 8, then it will be known as a stable atom. So don't get confused with what is 18 and what is 8. 8 as per the octet rule and 18 as per the Bohr's theory, which comes from 2 into n to the power 2. You got the point? Now, what is valency? So stable atom, you understood? Now, in order to make an atom stable, either atom will lose electron, or it will gain electron. Okay, either it will lose or it will gain electron. So which one is the easiest process? Atom will do that for itself in order to make itself as a stable atom. Either it will lose or gain electron. So in whichever the process, it requires less energy, it consumes less energy, it will go with that one. Okay, it will go with that one. So let's do that example. Let me take the example of neon. Let me take the example of neon. So neon is having 10, atomic number 2, 8. Now you tell me the outermost shell is having 8. So K will have maximum 2, L will have maximum 8. Now L can have maximum 8 and it has 8. So what will happen? 8 minus 8 equal to 0. So this is known as valency. Okay, this is known as valency. This valency calculation, I'll give you more examples. Don't worry about that one because this might be a little confusing. But if you understand the entire calculation, this will be amazing easy. So 8 minus 8 equal to 0. Why 8 minus 8 I said? Because maximum I can accumulate 8 in order to stabilize the atom. And I have only 8. So 8 minus 8. So I'm not losing. I'm neither losing nor gaining any atom. This is the valency is 0. Now let's talk about the next one. Example, hydrogen. Okay, hydrogen. So hydrogen atomic number is 1. Now if it is 1, then it will fit in the first shell. So in the first shell, maximum I can have 2. Yes or no? I can have maximum 2. But here I have 1. So what will happen? 2 minus 1 equal to 1. Why 2? Because I can have maximum 2, but I have only 1. Right? So how many more electrons I need? I need 1 more electron. So that this is a valency. Now let me give you one example of lithium. Lithium is 3. Okay? Lithium atomic number is 3. Now here 3 means what? Its configuration would be like for K2, L8, M8 and N2. Okay, as per the class 8 standard. So lithium is 3. 3 means 2 will be gone here and 1 will be here, right? So accordingly we write like this, 2, 1. You got the point? Now if I do this calculation, try to understand guys. In the outermost shell, if I do 8 minus 1, it is coming 7. Means 7 electron, right? And 2 minus 3, yes. And if I remove this one, just for example, if I remove this one, it means I'm just removing 1. So which one is the easiest one? 7 or 1? 1. Why I'm removing 1 from here? If I remove 1 from here, example, if I lose 1 electron from here, this will become stable, isn't it? This will become stable. Why it will become stable? Because the outermost shell has got 2 and it has also got 2. So that's the reason it will become stable. So removing electron or adding electron, which one is the easiest process will decide the valency of that particular atom. You got the point? I'll give you the last example of valency. Example, potassium. Potassium is 19. Okay? Potassium is 19. So let's do that one. 2, 8, 10. 10 plus 8, 16. Now, 2, 10, 10 plus 8, 8 plus 1. I'm sorry, 8 plus 1. 19. Right? Now you tell me what should be the valency for potassium. 2, 8, 8, 1. Now this is a rule. This is a rule. So this is fixed, fully occupied, fully filled, or fully occupied, fully occupied. So we are not going to see this one. We are going to see this one, the outermost shell, because valency is calculated based on the outermost shell. So the outermost shell is having 1, but we are supposed to have only 2. So what I'm going to do, 2 minus 1 equal to 1. Isn't it? 2 minus 1 equal to 1. So this is valency. Potassium valency is 1. So this is the way you have to calculate the valency, and I hope you have understood what is valence shell, valence electron, valency. But in order to understand valency, you need to understand the entire stuff. What is octet rule, why atom is stable, and other things. And hope you enjoy this session. And we'll meet in the next session with something really very important and a very critical topic which I will try my best to make you understand in a better way. Guys, this topic I have explained you based on the students' interest. And if you want me to explain you in a very better way, very simplest way, any of the topic from physics, chemistry, mathematics, or biology, please comment down in the comment section. I'll be surely coming out with the easiest way to explain you about that particular topic. Okay, so for the time being, thank you and bye-bye.